Sometimes troubleshooting your electrical issues is easy. Other times you need tools to figure out what's going on. Tools such as this multimeter. Multimeter can diagnose several issues in your electrical system, whether it be AC or DC, 120 volts or 9 volts, or 24 volts. So in this video I'm going to show you how to use one of these multimeters to check out your electricity, see if it can help you fix some issues, and I'll show you how to use it around the house, and then take a closer look afterward. We can take a deeper dive into the various different features on one of these. Let's take a look. This is a oscilloscope and multimeter in one. So this has a lot of functions. So we talked about using multimeters around the house. So you might want to get yourself a multimeter like this that has multiple functions, as the name implies, a multimeter. This one actually has even more functions than the typical multimeter because it's also an oscilloscope. It can measure different things like signal, the electric, the sine waves, and it comes with the probes, just like a regular multimeter. The caps, very, very sharp. Be careful with that. But when you plug in this one in, COM, the black one will go in COM, and red for functions such as continuity, diode, and temperature, up to 1000 volts DC. So you put that in there. If you're going to measure something like high current, then that would go in the 10 amp. This red one would go in the 10 amp. There's a different fuse in that part. But this would be for measuring milliamp. So it's 1 amp max fused. 10 amp max fused in this one. So if you tried to measure high current in this one, then it might blow that fuse. So yeah, it has a stand. And this one doesn't come with batteries, but it's nice that you can recharge it. Pry that open a little bit, but a C-type charge, so you can just charge this by your computer or with a wall adapter. These here are different. These are for the oscilloscope functions. All kinds of different things in here. It comes with a user guide. Oscilloscope probes. You can see the different alligator clips that clip onto this, and the different probes, and of course a C-type USB charger cable. And select. That's pretty cool. It can either do oscilloscope, signal generator, settings, multimeter. Let's do multimeter now. Okay, so which one? So you just press right. So it's pretty self-explanatory. It's got a really nice carrying case with a handle. So really bright screen. Pretty much read it in a very low light setting or no light. So let's start doing voltage. Let's test and see what happens. So we have a volt here, DC voltage, max 68 millivolts. Let's see if we can measure 1.59, if you could see that. Put this down. You want. So this is testing the battery. Very quick, very easy. I just had the probes backwards. That's what that negative was. But if you put them in the right positive and negative, as you see there, then it won't be negative. So similarly, you can just test. There's 3 volts on this. That's good. This is supposed to be 3 volts. And a 9-volt battery. I think we know what this is going to be. This one's not going to be good. A little bit less. Definitely don't want to use it on something that needs a 9-volt, but that's handy to have an oscilloscope multimeter to be able to test it. I can use this for some DC electronics to step it down to 5 volts, for example, so it's not completely dead. But you wouldn't want to put this in your smoke detector. So this is pretty cool. We have, what else we have? So this one is a continuity tester. So if we can get a fuse, let's see if we can measure a fuse. So a couple of auto fuses, not that expensive, but nice to be able to test. So this one's looking kind of dirty. This is 20 amps. So that's a large fuse. Let's see if I took it out of a car because it didn't work. Oh, it's pretty loud. So that is a good fuse, obviously. What it does is it sends a small amount of current through, and I don't know if you can see, but the tiny little piece of metal in there, if too much current goes through it, it blows. So what this does is it sends a little bit of current, and it tests to see if it makes a connection, or technically if it's measuring the resistance. If it remains OL, see, that was, you saw how it changed. If it remains OL and doesn't beep, then this fuse would have been blown. But this right here is the ohms symbol. Nice handy, lights up. So this is measuring resistance. So if you don't know, if you have a resistor or something, you might have a auto resistor. You might have like the larger auto resistors in line with some of your electronics in your car, and you want to see what resistance you have. Okay, so 2K ohms. And that's what this is. This is a 2K resistor. That's what that would be. You can obviously plug a light bulb in to see if it works, but there is a tiniest amount of a connection in there. I'm going to kind of see when you know the power goes in through one side. Yeah, about 28 ohms. So that's about normal. You might need to test AC voltage, and in that case, these really sharp, you have to be careful, but because they're so sharp, they can get into such small spaces. Even if this is wrapped in electrical tape, you can kind of test your red lead on the brass colored screw, and then your black on the green colored screw, the ground, to see if it's grounded. Should get 120 volts AC through that. If you do it that way, or put the black on the silver screw to make sure that you have power coming through, whether it's grounded or not. And that would be voltage. It knows. You don't even need this put a setting, it just knows. Let's see if this one may not do capacitance. Let's find out. So, no, it's giving me the resistance. So I figured out resistance. Let's see if it figures out voltage. Yeah, it figured out DC voltage. So it should figure out automatically if you put this on the voltage, if it's AC voltage. So that's pretty handy. Let's see what it does for temperature. There you go, AC voltage by hitting this move button. Now I would be able to test something like a socket. And these things, it shows the insulated, so it's insulated up to 1,000 volts and 20 amps. So we have to be very careful with that. It's insulated up to those currents. So you should be able to test. This would be the hot side, and that would be, and that's basically just touching the conductor with an insulated probe. You could do the same with a light socket. The outside is the neutral, and then if you touch the inside, that is where the hot is. And then if you touch those two, you should be able to see 120 volts. So if your light bulb's not working, you want to see if your circuit is good, you could test that. Similarly with a switch. Switches, you only have a certain number of switches before it goes bad, but it should be an open circuit when it's off, and then when it switches on, it should be a closed circuit. So if power's not going through, then the switch is bad. Let's see what happens if I do temperature. See if we can get, if these probes test the temperature. So that's Fahrenheit. So it's basically reading room temperature. So that's about right. And then milliamps. So this is measuring current. And for that, on this multimeter, you would put the red probe in the milliamp port there. The black probe will stay in COM. And what I have here is a simple LED circuit. It sends current through this resistor here into this LED and then back to ground. So if I connect that circuit and put this in ground, hopefully you can see on the screen that that is green. It's glowing green and it's completing the circuit. So what I want to do is I want to put this in the middle of it. I want to put this in series with the circuit, not parallel. I want it to complete the circuit so I can see how much current is coming through with this resistor. So I got a multimeter, and let's see what happens if I keep it on auto. So what I'm going to do is I'm going to break this, okay, and then from here I want to complete that circuit and see what happens. So there you go. So we have a completed circuit there, and nothing happened with the auto. So let's set it to milliamps current. There we go. And we have 26 milliamps. Perfect. And just to see if we could get a different, reading, I'm just going to replace it with a different resistor. I'm just going to grab a, I didn't even get a reading on this, so let's try this one. Last one you saw was about 26. Let's see what this gets. Much less, 1.5 milliamps. So what that tells us is that this is a higher resistor, so it's allowing less current to go through. While I'm at it, I'm going to put this back on the diode test, see if we can do a diode test. Can't seem to get it to 1.9 volts diode. Yeah, you couldn't see it, but it was sending a tiny amount of current through that LED, and then now it does not send it when I reverse the polarity, because diodes only send current through one direction. That includes light emitting diodes, or LEDs. You can barely see it, but it does light up when I put it at the right polarity. When on auto, it should automatically detect AC or DC and to see what I'm trying to do. So here I'm trying to see if there's power coming to this light socket, this lamp holder. As I'm sure you know, so you have the power goes in through the bottom of a bulb. That's where the hot is. And then the outside, if it's wired properly, should be the neutral that completes the circuit. 118 volts. Okay, so that means there's power going to it. To see if something is grounded, this metal should be grounded. So I should be able to send 120 volts through the metal back through the ground. And it does not. That tells me that this is not grounded. So I know that metal in there does not have a ground going to a ground screw. Outlet, a receptacle. It's on auto again. So if we put the hot lead into the small slot and this black lead going to come into the larger slot, that's the neutral slot. The smaller part is the hot, it should read 120 volts AC, and it should automatically detect it with this particular one. Remember, these are insulated up to 1,000 volts. Obviously, you wouldn't put anything in there that isn't insulated. Okay. 117 volts, so that's expected. I'm going to see again if this is grounded. So we have voltage. 50 volts, so not all the volts are going, so it doesn't have a good ground connection back. You can do the same with any outlet that you see. You have the small slot is the hot, and the wider slot is the neutral. So I'm going to, again, carefully, so we have on auto, it should automatically detect it. Okay, so we know there's no power, and of course if you plugged it in, nothing would happen, but it's good to be able to see what kind of voltage is going through. Your multimeter will also detect low voltage. This would be about 16 volts. That's a transformer sending out wires to a doorbell, which would read about 16 volts, not 120. So basically it's stepping down the voltage there. Similarly with a thermostat, it'll step it down to 24 volts. Okay, back to auto. Let's see if we can get 24 volts reading here. Okay, well that was a continuity test. Let's see if we can do AC voltage here. There we go. About 20, just under 20 volts. Now my channel is not a electronics channel, but this multimeter comes with an oscilloscope, and I just wanted to touch on how to use that with this handheld oscilloscope. Like I said, I'm not really an expert in electronics. I dabble at the hobby level, so I won't be able to give you a complete rundown of everything an oscilloscope does and what you can do with this, but I'll show you just the basics. This is my oscilloscope. It's on the floor here. A gigantic thing, and it has a CRT screen, so it needs a massive amount of space, and it has a little handle on the top, but it's barely luggable, as they say. It's not exactly portable, it is luggable. You can lug it around. This little thing can do basically the same thing as this, almost just as much. Just like this, it has a screen where you'll see the signal, which is basically voltage over time. On X you have the time, and you even see that running right now. When I use the multimeter to measure voltage, I would touch the probes on hot and neutral, and then I would get basically a snapshot in time what the voltage was reading. But that's just a snapshot. But when you do an oscilloscope, it's basically time as it's happening. So you see the ups and downs. In America, it's 60 hertz, 60 times per second. Power, electricity, that voltage goes up and down or back and forth, however you want to put it. And you use an oscilloscope to see how that signal changes over time, and to see if you can use it, for example, an audio circuit, analog audio, digital audio with pulse width modulation, where it basically mimics an analog sine wave digitally, similar to how an MP3 kind of breaks down the analog signal, and then you can see it on this screen. And this has a screen not really much smaller, and you can snapshot and save pictures of the screen, which is something you could not do with this. This is a very old, basically an antique, and it looks like it's for Bell and Howell schools. So this would have been used as in a lab at a school. And like I said, I'm not an expert, not going to go into everything you can do with it, but let's see this little handheld oscilloscope can do the same thing that this large luggable old oscilloscope can do. Okay, just to give you an idea of what you can do with an oscilloscope, I put the leads on channel 1. You have channel 1, channel 2, and this one is a signal generator. And that signal generator has a separate one with separate alligator clips. And of course all of these come in the package, in the case when you get this. And what I did was I attached the ground. I attached channel 1, that's the one at the top, and you have another channel that you can compare it to, channel 2. I attached the ground to this circuit, which I hope you would find as charming as I do. It is a little thing I made with Rudolph the Red-Nosed Reindeer, and it has a red nose. And it makes the first few notes of the famous song. And that is in digital sounds. So it sends little frequencies out. And so you can see at the top channel, when I hit play, well, not really hit play, but when I attach the ground of this battery in there, you can see the digital signal and see how it is a square wave. And then it goes flat line. As you can see, the notes, different notes look different. And there you go. That is the basics of reading a digital voltage signal. Hopefully my video does not get a copyright claim for that song. I'll have to edit it out. But you can see that signal. So there you go. So there's this little 2C53T. Honestly, if you want to delve into more of the oscilloscope features, I would actually recommend looking at other YouTube videos of this exact handheld tool. This video hopefully shed some light on how to use a multimeter around the house. You can, if you tinker with electronics, you can buy this one because it has an oscilloscope 2-in-1. So it's oscilloscope and multimeter. I've had fun testing this thing out. The various, I haven't really touched on the signal generator. Like I said, it generates a signal. You can go into settings. So the multimeter, the oscilloscope, barely touched on. So I recommend looking more into that. If you have a use for an oscilloscope, you can find a video that really does a deep dive into that. But what I liked the best about this was the auto. So I would say 4 out of 5 times the auto multimeter auto setting figured out what you were trying to do using the probes. Very sharp, pretty much able to go into even like a breadboard or very precisely on a pin. Again, if you're doing electronics, troubleshooting a circuit board and HVAC or something, pretty much anything else, computers, and these are really good leads for that. And another cool thing is that, and this is kind of hard to open, but it's really hard to open. But that pops open, USB-C charge, which is really cool. So I charge it once, battery's still full even after tinkering around with it. So don't have to worry about buying the AA batteries, AAA batteries, or 9 volts. So just recharge it. Pretty cool. You can go up on a screw. Has a stand. We went through this. We have the common, and this is for testing milliamps. And then this one up to 10 amps for high current. And then everything else, you put the red lead on this part here. And auto usually will figure it out, but if not, then you can always go through the settings to test voltage, resistance, continuity test, diode setting, capacitance, which I didn't get into much, and even temperature. And of course, DC and AC voltage. So hopefully this helped you out. The link for this is in the description if you want. I don't get a commission on that. They've been nice enough to supply this for me to be able to show it to you. And yeah, check it out. Thanks for watching.